Howdy-ho, neighbors. It's Mr. Orgic, and it is now Unit 9, Lesson 7. We're almost there, so hang in there. One more to go after this baby, and we'll have this unit out of the way. All right, this one has to deal with solving quadratics, so our objective will be to solve quadratic equations using any of the three methods learned. You should recall them to be factoring, completing the square, and then in the last one, the great and almighty quadratic formula. And we are going to use those now to solve equations, and they'll be mixed up in different orders and another little twist in there. But everything you already know, just add a little bit more, not the major, okay? Hang in there, let's go to exercise 1. All right, in exercise 1, we're going to solve them. There's 4 of them actually to do. The first one's by factoring. But the key here that you notice is I do not have the equation set equal to 0. And that is really going to be the twist that we're going to do in all of exercise 1. So I got to get this stuff over to the other side. So first step obviously is to minus 8x, which means it goes under the 5x here because those are like terms. And the opposite of minus 2 is plus 2. I'm going to take care of them, and that goes with the 12. So when I get done here, I get an x squared. I'll clean this up. And 5x minus 8x is a minus 3x. And a minus 12 plus 2 is a minus 10, equaling 0. Now we got a trinomial. There is no GCF that we can handle here. So we are going to do the normal 2 binomial factoring. X squared is x and x. 10, you got 2 choices, 1 and 10, 2 and 5. Which pair subtracts to 3? Once again, you can use that the reverse FOIL, reverse box method, okay? Obviously, I know 5 and 2 subtract to 3, so I'm going to bring down the minus sign. The 5 is bigger. That means the 2 goes over here. And since it's a minus sign there on the second one, it's got both different signs, so that's minus. This guy has to be plus. Turn around, T-split it. And if you do the work, x will turn out to be positive 5. And on this one, x will turn out to be a negative 2. I'm shortcutting it. Don't do that on a quiz or exam, okay? But there we go. Those are 2 answers, 5 and negative 2. All right, part B now. We've got completing the square. Completing the square, same thing. Extra stuff on this side, got to move it over. So we're going to move it over. And I'm going to bring the 3x over here. And I'm going to bring the 4 there. So I will get an x squared. A positive 3x when I bring it over. So it'll be a minus 12x total. You should show the steps if you need to see them. And then this is a 24, and that's going to be a minus 4 when I bring it over. So that's going to be plus 20 equals 0. Okay? So obviously we have our x squared, our minus 12x. Leave a little space, plus 20 equals 0. Oops, sorry, leave a little more space here. Equals 0. I'll clean that up in a moment. All right, half of negative 12 is negative 6 squared is a positive 36. So if I add 36, how about that? I need that minus sign. You do a minus 36 there. These guys, once again, are x minus 6 squared. And these two turn out to be a negative 16 equals 0. Okay? Bring the 16 to the other side. You get x minus 6 squared equals 16. Change the colors here. I'm going to take the square root of both sides. Don't forget plus or minus over here. And I will end up getting that x minus 6 is equal to plus or minus 4. That means I have 2 answers once I add 6 to both sides. I have a 6 plus a 4, which is 10 as an answer. Bingo. And I have a 6 and a minus a 4, which means 2 is my other answer. Okay. So that's parts A and B. Let's roll to the next page to C and D. All right, letter C is going to be our quadratic formula. But once again, you have stuff on the other side. It is not set equal to 0. Therefore, we must move it first. So we got to move 5x over, minus 5x, both sides. Minus 5x. And a minus 15. And that's going to be tough to fit in there, minus 15. Okay, when I do that, I get x squared minus an 8x. And opposite, plus 1 equals 0. Therefore, my A is 1, my B is negative 8, and my C is equal to 1. Even if they hadn't told us that we had to do that this way, we would turn around and say, hey, there are no factors of 1 that add up to 8. It's not going to happen. So, using the quadratic formula, here we go. X equals the opposite of negative 8. So, the negative of negative 8 plus or minus the square root of negative 8 being squared minus 4 times A is 1 times C is 1. All divided by 2 times A is 1. So I will get a negative of negative 8, like I said, is positive 8 plus or minus the square root of 64 minus 4 all over 2 times 1 is 2. So X equals 8 plus or minus the square root of 60 over 2. Square root of 60, you can get 4 in there times 15. So you're going to have 8 plus or minus, well, the square root of 4 is 2. 15, yeah, it's 3 and 5, but you can't bust it up anymore, so square root of 15 stays all over 2. Then we do like I normally do, which is divide 2 into both. These 2's will cancel, and this 2 also will go into this one. So you got to divide 2 into both. And you're looking at an answer like this. X is equal to 8 divided by 2 is 4, plus or minus, and then 2's gone, square root of 15. And that is your answer for this one. Now it did say the nearest tenth. So you're going to have to plug that in your calculator and do 4 plus the square root of 15 and 4 minus the square root of 15. Okay? And you get a couple answers here as far as this goes. Let's see here. I actually get... Oh, I didn't do it. Pause the video. Hold on one sec. Okay, so when you change them in there, you get actually 0.1, so 1/10, and 7.9. Those are your two answers to the nearest tenth. Okay, pause the video now, and I want you to try D on your own, but this one you will not change the nearest tenth. It does say simplest radical form. And then come back and check to see what you got compared to what I have. Okay, so pause the video, and if you take a look at your answer on D, should match up with me at -3 plus or minus the square root of 14. So look it over and we'll see what I did. Any questions, ask us at school tomorrow. Okay, moving on now to exercise 2. Alright, exercise 2 is going to be a good one on understanding what we just did in the last chapter and see if you grasp it or not on quadratics. But the bottom line here is, it says, what are the values of h and k? Well, if you remember correctly here, the h and the k make up our turning point. Okay? So where's our turning point? Right here. And that point, of course, is over 2 up 4. Okay? So that's where your h is, 2, 4. All right. What happens if you try to solve it? Well, if I try to solve this thing here, you actually would have, if you set it equal to 0 to get the zeros and stuff like that, you would have an x, and the 2 is a positive 2. Remember, we always want the opposite on that. So that's a -2. So actually your h there, squared. And then we've got a plus 4, and that would be equal to 0. You would move the 4 to the other side, -4. You get an x minus 2 squared then equals -4. And then we do the usual, take the square root of both sides. Okay, and so then we're going to have x minus 2 equals, and hold on a second, plus or minus, we can't take the square root of a negative, remember, okay? No negative right there, so that's the big baby right there. That means we have no real roots. Once again, and that should make sense when you look at the picture here, because does it ever hit down here on the x-axis? No, it never comes down and touches or goes by it. So there are no real roots in this, and that you just proved. So this one wouldn't work as far as it goes. Once again, we will tackle this, and this can be solved, but not until the Algebra 2 course when we deal with imaginary numbers, okay? So you almost got caught up in that one. Let's move on to number 4. All right, our last exercise here basically tells us, it says go ahead and basically do the quadratic formula on each of these to see where it has real zeros or not. And we're trying to find one that has no real zeros. So just like we had before, the negative under the square root, the radical sign here. I'm going to do the first one real quick, just once again review. I know that my A is equal to 1, my B is equal to 7, and my C is equal to 1. So we'll get x equals the negative of 7 plus or minus the square root of 7 squared, and then minus 4 times 1 times 1. Okay? That means x is equal to, oh, don't forget that this is what a lot of people do, 2 times a on the bottom of 1. All right, so we get a negative 7 plus or minus, okay, 49 minus 4. It's real tough using the stylus sometimes. Divided by 2. So x is equal to negative 7 plus or minus the square root of 45 divided by 2. And I'm not going to have an issue there. It didn't actually, let's see here. They wanted to know which one would have no real zeros. This is a positive thing right here, so we're okay. We will have real roots. So this one has real roots. I won't finish it off because it didn't say you had to have the actual answer. Okay? Pause the video right now, and I want you to do B and C, and then come back and compare yours to mine. So pause away, try the other two here. All right, you should have these two, and I'm going to stop both at that point without finishing it. But here's the deal. This guy, square root of 64, no problem. That's 8. That's a nice number. This will have real root, so it has real roots. Okay? No problem there. However, this guy here has a negative under the radical. No real roots. And that's what they want to get at. Okay, and they actually do something called a discriminant, more in an Algebra 2 course, that deals with this all the time, which one has imaginary number in it. So this thing's going to have an imaginary root in the middle, but the other two do have real roots. If we finish them off, have actual answers, okay? So that's what you got today. The key points here and objectives, be able to solve these guys. And the bottom line is, in every case today, in the beginning especially, you had to get everything on one side and set it equal to 0. So you might have to do a little algebra, move it over. And then you've got options of factoring, completing the square, quadratic formula. And watch out for this little guy right here like we have here. When you have a negative under radical, you're not going to actually have a real root solution, okay? Write a nice WSQ. One more lesson to go in this unit, all right? Hang in there.